In this video, I'll be completing every problem from the 2012 AMC8, going over some solutions. I'll see if I can get them all done in 40 minutes. I'll set my timer right here. Just like I just uploaded the one from 2011 last time, which was my 8th grade year. This is technically the first year after I graduated, so maybe my first year as an assistant coach, if I went back freshman year. But let me pull this up. I've got 40 minutes on my timer going. I'll put that behind me. This is hopefully somewhat visible. There we go. And I guess with that, I'll dive in. So I got to close this out. And there are 25 questions. So we'll start right here. They usually start with pretty easy ones. So it says, Rachel uses 3 pounds of meat to make 8 hamburgers for her family. How many pounds of meat does she need to make 24 hamburgers? All right, well, just scaling it up. So 8 times 3 is 24. So we have to multiply that 3 times 3, and it gives us 9. So that'd be E, 9 pounds of meat. In the country of East Westmore, statisticians estimate that there is a baby born every 8 hours and a death every day. Okay, so every 8 hours, that would go into 24 3 times. It's the second time they did 8 times 3 is 24. So that means there are basically 3 babies born a day and 1 death a day. So it's a net change of plus 2 people each day. To the nearest 100, how many people are added to the population of East Westmore each year? It doesn't say anything about anyone like moving or moving in or out. So we'll just assume it's just based on this. 2 times 365, or technically 365.25 if we're doing the accounting for leap years. But to the nearest 100, we're rounding it anyway. It looks like it's going to be 700. That would be 730, which is closer to 700 than 800. So that would be B. On February 13th, the Oshkosh Northwester, I think that's in Wisconsin, which is where I am right now. But the Oshkosh Northwester listed the length of daylight as 10 hours and 24 minutes, and sunrise was 6:57 a.m., and sunset was 8:15 p.m. That doesn't make sense. That's like not 14 hours after, but almost closer to like over 13 hours after. Okay, let's see what they say. The length of daylight and sunrise were correct, but the sunset was wrong. Okay, so 8:15 is wrong. Yeah, that would, because it's over 12 hours if it's like the same time but later in PM. Anyway, when did the sun really set? Okay, so we're just adding 10 hours, 24 minutes to 6:57. Well, I'll start with the 24 minutes. I feel like that's easier. So 6:57 a.m. plus 24 minutes would be 7:21 a.m. And then 10 hours after that. Well, if you add 12 hours, so plus 12 would be 7:21 p.m. And then we want to do minus 2 hours, which would bring you to 5:21 p.m. I think that's the easiest way to do it. It would be B. Okay, so we had EBB. Peter's family ordered a 12-slice pizza for dinner. Peter ate 1 slice and shared another slice equally with his brother Paul. What fraction of the pizza did Peter eat? All right, they had a 12-slice pizza. Peter had 1, shared another slice equally with his brother. Oh, I was like, share, like he just gave his brother that slice. No, he like split that. So he had 1.5. He had 1.5 out of 12, which, I mean, if you double that, that's going to be 3 out of 24, which then you can divide those both by 3, and you get that's 1/8. So you had 1/8 of the pizza. All right, that was a kind of weird way. They should have said they split it, not shared it, but whatever. All right, in the diagram, all angles are right angles, and the lengths of the sides are given in centimeters. Note the diagram is not drawn to scale. What is x in centimeters? Okay, well, we just have to figure out, I guess the height will be the same on this side as it is on this side. So over here we've got 1, 2, 3, plus 2 is 5, plus x. So it's 5 plus x over here. And then make sure I didn't miss any parts of it. Then over here we've got 6 plus 1 plus 2 plus 1. So 1 plus 2 is 3, plus 1 is 4, 4 plus 6 is 10. So 5 plus x is equal to 10, which means x has got to be 5. And so 5 is going to be E. A rectangular photograph is placed in a frame that forms a border 2 inches wide on all sides. of the photograph. Okay. The photograph measures 8 inches high and 10 inches wide. So it's 8 by 10, like that. What is the area of the border in square inches? All right, well, it's going 2 beyond that, right? 2 beyond that in every direction. Is that what it said? 2 inches. So that will go like this. So if it was 10, then you're adding 2 to each side, it's going to be 14. And it was 8, but you're adding 2 to each side, that would be 12. So 12 by 14 is like the total area of that. I think they want you to subtract the inner part, but let's figure that out. So 12 times 12 is 144, and then we want to add 2 more 12, so add 24 to that, which gives us 168. So 168 would be like the entire thing, including the photo. Now we want to subtract the photo, which is 8 times 10 is 80. So minus 80 from that gives us 88. So that'd be E. All right. Isabella must take 4 100-point tests in her math class. Her goal is to achieve an average grade of 95 on the tests. Her first two test scores were 97 and 91. After seeing her score on the third test, she realized she can still reach her goal. What is the lowest possible score she could have made on the third test? So I'm assuming you can't get bonus points. So basically, what's the lowest? That would mean that for it to be the lowest, then on the last, there's 4 tests. On the last test, she would expect to get 100, right? Because it's the lowest possible. It's like, well, 100 is possible. So 100, 97, 91, and X. When you add these all up and divide by 4, they would give you her goal, which is 95. Right? Now what we can do is multiply both sides by 4, and we get, let's see, X plus, well, if we add these all up, 91 plus 97 is 188, plus 100 is 288. So X plus 288 equals 95 times 4, right? Because times 4 over here cancels this, times 4 over here. It'd be 400 minus 5 times 4. So 400 minus 20 would be 380. So she needs these scores to all add up to 380. So I can subtract 288 from both sides, and we get that X is equal to, well, it's basically 100 minus 8, right? So 100 minus 8 would be 92. So she gets a 92, then it's still possible to average a 95 if you get 100 on that fourth test. All right, so that'd be B. All right, next we have, I'm kind of writing onto here, let me see. A shop advertises everything is half price in today's sale. In addition, a coupon gives a 20% discount on sale prices. Using the coupon, the price today represents what percentage off the original price? All right, so it's 0.5 for, it's everything's half price. And then you're multiplying that by, you're taking 20% off of the whole, right? So it's a 20% discount, so 20% less than 100. So that's 80%. So you actually have to multiply 0.5 times 0.8. And 5 times 8 is 40. So this is going to be 0.4, which is 40% is what you're paying. What percentage off the original price, though? If you're paying 40%, that means you got 60% off. Which also makes sense. None of these would make sense because if you already got half off, then you're getting more than half off with the additional coupon. Okay, that looks good. So this will be D. The Fort Worth Zoo has a number of two-legged bids. The Fort Worth Zoo has a number of two-legged birds and a number of four-legged mammals. On one visit to the zoo, Margie counted 200 heads and 522 legs. How many of the animals that Margie counted were two-legged birds? And we're assuming all the birds and all the mammals have heads, I guess. How many of the animals? Okay, well, basically we know there are 200 total animals. So the way you can set this up, I mean, I think there might be an easier way because it's question 9 on an AMC, but if I want to do a system of equations, I could say B is the number of birds. Actually, I'm not going to write a B over there because that looks like my answers. So B is the number of birds, and we'll do M is the number of mammals, but B plus M, the total number of birds plus the number of mammals, is the total number of heads, so that'd be 200. And then we can also do, okay, number of legs, 2 times B is the number of bird legs, plus 4 times M is going to be the number of mammal legs, and that will add up to 522. Okay, so we've got 2 equations now. How many of the animals that Margie counted were two-legged birds? So it just wants to know how many B's are there, basically. How many How many B's? So what I can do is I can multiply this entire top by 4. So 4 times B, 4 times M, 4 times 200 is going to be 800. And now I can subtract this second equation from that because it will get rid of all the M's. This is called elimination. So I'm getting rid of the 4 M's from both equations. 4M minus 4M is 0. 800 minus 522, that would be 278. And then 4B minus 2B is going to be 2B. So 2 times B is equal to 278. I just want to figure out how many birds there are. How many of the animals that Margie counted were two-legged birds. So I need to find 1B, divide both sides by 2. Yeah, 2B divided by 2 is just B. And then 278 divided by 2, well, 200 divided by 2 is 100. And then 78, well, that's 39 times 2. Because 40 times 2 would be 80, and you're taking 2 off and divided by 2. So 139 birds. And if you want to check that, you just do 139, let's see, 800 minus 139, that would mean there are how many mammals? There would be 661 animals, or mammals. And then, no, that's not right. It's not supposed to be 800, it's supposed to be 200. So the mammals would be 200 minus 139, which would be just 61. So 61 times 4 would be 244. 244 mammal legs, plus the bird legs would be 139 times 2. We already know that's 278. 278 plus 244 is, in fact, 522. Yeah, because that would be 2, carry the 1, 8, 2. Yes, okay, that would be 522. Perfect, so that does check out. This one is C. All right, how many 4-digit numbers greater than 1,000 are there that use the 4 digits of 2012? So I get rid of some of this stuff. Was this supposed to be a B? How many 4-digit numbers are there that use the 4 digits of 2012? Okay, so it's just like how many ways can you rearrange these where you're not having a 0 at the beginning? Because if it's greater than 1,000, it can't be 0, 1, 2, 2 or something like that, or 0, 2, 1, 1. Okay, so basically, the way we can do this, there are 3 options, right? You can use either the 2, or the 1, or the 2. So 3 options for the first spot, because it could be any of those letters except 0. And then there are 3 options for the second spot, and then there are 2 options for the third spot, and then just the last digit would go last, right? So it would be like that. That would be if they were all 4 distinct digits, 3 times 3 times 2 times 1. Now we also have to account for the fact it doesn't matter which 2 goes where. So the order of those 2 just doesn't matter, which you'd be like, how many ways can you arrange those 2 things? Well, just 2. It's like one of them's here, one of them's here. So just divide by 2 to account for that. And then 2 divided by 2 cancels out, and that just leaves 3 times 3, which is 9. So there should be 9 ways to make that work. Since it's only 9, we could probably list them all out. Maybe I'll come back to this one. I'll put a little star. I'm pretty confident in it, but just like, if you see it's a really small number, it's probably doable to write them all out. Now, that wouldn't necessarily confirm that it's not 12, but that could at least confirm it's not 6, 7, or 8 if you can find 9 that are distinct. All right, the mean, median, and unique mode of the positive integers 3, 4, 5, 6, 6, 7, and x are all equal. What is the value of x? So the way they wrote it makes it look like x is bigger than 7 because the other ones are all in order, but it isn't necessarily. And I'm going to guess it's probably not. What is the value of x? I'm just guessing that because that would be a good way to make it harder to do. So it's a unique mode. So it's the only one that is the mode, which basically means that the mode is 6. So none of the other digits could be repeated. So it can't be 7 and it can't be 5 then. It could be 6, right? You could have 3 6s, but it wouldn't be a unique mode if there are 2 5s or 2 7s. Okay, we know... Oh, the mean, median, and mode are all the same. So right now, 1, 2, 3, 4, 5, 6, 7. There's 7 numbers. So the median would be the 4th number when they're listed in order. So that means it could be more than 6. It just can't be less than 6, or it could be equal to 6. So that would also rule out 5, but we already knew it wasn't 5. Okay. Although if you add a number over there, yeah, then that's still the middle. And then for the mean to be 6, that's the I think that's the way that you solve this here. So if the mean is 6, there are, we said 7 numbers, so they're going to add up to 7 times 6, because to find the mean, you would add them all up, divide by 6. So if you multiply by 6, you can get the sum. 7 times 6 is going to be 42. So 42 is the sum of all of these numbers, and then we can just use that to figure out what x is. So 3 plus 4 is 7, plus 5 is 12, plus 6 plus 6 is 24, plus 7 is going to be 31. So 31 plus x would add up to 42, which means x has to be 11. Okay, so I was wrong. X actually is in that position. If you list them in order, it's the biggest one. So that would be D, 11. What is the units digit of 13 to the 2012 power? Okay, so this one, the units digit, they had one on the last one that was a tens digit. How am I doing on time? I'm wasting a lot of time yapping here. All right, I'm going to have to pick it up here, but 3, so if it's the first power, then it's 3. If it's squared, 3 times 3 is 9. If it's cubed, that's 3 cubed is 27. 3 times 7 is 21. And then it's going to be 1 times 3 would be 3. So basically, any multiple of 4 power would end in 1. And then from there, you just count on. Now, 2012 is a multiple of 4, so it's going to end in just 1. That's just A. All right. We're only halfway done, but we're already like halfway through the time. And they do tend to get a little harder as we go, or a little bit longer. But let's see. Jamar bought some pencils costing more than a penny each at the school bookstore and paid $1.43. Sharona bought some of the same pencils and paid $1.87. Okay, how many more pencils did Sharona buy than Jamar? All right, well, how much more? She paid 44 cents more? Is that right? So if she paid 44 cents more, it could be 44, it could be 22, it could be, I mean, I guess we could just figure out the prime factorization of 44. 22 times 2, which is 2 times 11. Okay, so it could be really any factor of 44. I'm thinking it's going to have to be 11, would be the cost. This is how many more pencils did she buy. The 11, because it has to be possible to get 143 and to get 187. And those are both multiples of 11 cents. I know that because to multiply something by 11, that's a 2-digit number, like 11 times, in this case, 13. 11 times 13, you just put the tens digit in the hundreds place, you put the ones digit in the ones place, then you add those two up, and if they're less than 10, you just put that in the middle. So 143. Same thing here. 17 times 11 would be 1, 7, right? Put the tens place in the hundreds, ones in the tens. 1 plus 7 is 8, which is less than 10. So just put it there. If it was 10 or more, then you would just have to add it to that hundreds place digit. But so that means basically, if that's possible, so the price was probably 11, and Sharona bought 17 compared to Jamar, who bought 13. So Sharona bought 4 more. So the answer would be C. All right. In the Big N, a middle school football conference, each team plays every other team exactly once. Okay, this is like the handshake problem, it looks like. If a total of 21 conference games were played during the 2012 season, how many teams were members of the Big N conference? So the handshake problem, how it works is like, basically if there were some number of people in a room, so say there were like 5 people in a room and everyone shakes everyone's hand, then it would be 5 times 1 less than 5. So 5 times 4 would be the number of handshakes if you count it for each person, right? Because each person, each of the 5 people would shake 4 hands. But then you have to divide it by 2 because, it's the same handshake if I shake my friend's hand or if my friend shakes my hand. So it'd be 5 times 4 divided by 2. So basically we have x times x minus 1 divided by 2 is equal to 21. And let's see if we can just solve it like this. So times 2 on both sides gives us x times x minus 1 is equal to 42. Well, we already know then what number times the number less than itself would give you 42, 1 less than itself. This is 7 and 6, or 6, 7. So 7 times 6, so that means x is 7. There are 7 teams. Is that what they're asking? How many teams were in the thing? Yeah, there are 7 teams in that conference. And then they would each shake 6 other hands, but then, or not 6, but play 6 other teams, but then, the games go both ways. Okay, perfect. And they say they play each team once? Exactly once, right? Okay. I was just checking to make sure they're not playing everyone twice. I guess then they wouldn't get 21 games. All right, the smallest number greater than 2 that leaves a remainder of 2 when divided by 3, 4, 5, or 6 lies between what numbers? This one's tough. Okay. Smallest number greater than 2 that leaves a remainder of 2 when divided by... Okay, so basically we want to find a multiple of 3, 4, 5, and of 6. Like the least common multiple of those, and then add 2 to it. Because it would be like something that those all go into evenly, and then you have 2 left over. Right, so the way we can do that is we do 3 times 4 is 2 times 2 times 5. And then we don't have to multiply by 6 because we already have 2 times 3, which would give you the 6. All right, so that's going to be 4 times 3 is 12 times 5 is 60. So it's 60. And then you have to add 2 to account for, right, the remainder of 2. So plus 2, it's 62. You can check that by dividing all of those, 62 by all of those. But that would be between 61 and 65, so that's D. That's kind of interesting that they did it like this with the ranges, so you can't just plug in the different answers and see which one gives you that remainder for all of those options. Okay. Each of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is used only once to make 2 5-digit numbers so that they have the largest possible sum. Which of the following could be one of those numbers? Okay, so basically you're going to want the 2 biggest digits to be the, like, what is that, the 10,000s place, like the last place. So it's going to be 9 or 8 here. And now they could really be any pairing. But then for the next one, you'd want the next 2 biggest digits, so 7 and 6. And then the next 2 digits, so 5 and 4. And then this would be 3 and 2. And then the last would be 1 and 0. Okay. So basically, we need one that has either 9 or 8 in the first spot. So we can eliminate A, because that has 7 there. Then for the second spot, it needs either 6 or 7. They all do that. Then the next spot, it needs to be either 5 or 4. This has a 7 there. That doesn't make any sense. This has a 4. This is a 2, it's not right. This is a 4. And then the next one has to be either a 3 or a 2. So that's got to be C, because this one is a 0. Okay, so it's going to be C. Right, and it doesn't matter, because either way you're getting, like, it doesn't have to be like all of these together, all of these together. It's just one of these first, then one of these second, then one of these third, then one of these fourth, then one of these fifth for each of the numbers. And then whichever number wasn't in that first number goes into the other number. All right. A square with integer side lengths is cut into 10 squares. How does that work? All of which have integer side lengths, and at least 8 of which have an area of 1. Oh, they're not congruent to each other. Okay, that makes sense. What is the smallest possible value of the length of the side of the original square? Integer side lengths, all of which also have integer side lengths. Okay, well, I'm trying to think how you could make this work. Because you can't make it out of 10 1-by-1 squares, because 10 is not a perfect square. But we basically want to figure out, okay, 1-by-1 would give you an area of 1, a 2-by-2 would give you an area of 4. And then, 3-by-3 would give you an area of 9. Guessing they don't get bigger than that, but we could think about this for a second. It might only be 1s and 4s, honestly. So basically, the next square after 9, because it's not a 3-by-3, because it's got to have at least 10 square units in it, would be 16. So 3 squared, then 4 squared. So is there some way we can add up 10 of these to give us 16, is the question. Well, no, I don't know about that. What is the possible value of the... Okay, so for one, we already know that the original square is not a 3-by-3. So it could either have an area of 16, it could have an area of 25, an area of 36, or an area of 49. Okay. With 10 of these. So if they were all 1s, the area would be 10. And then for every one that you change to be a 4, you're increasing the area by 3. So you'd have to have 2 4s. So a 2-by-2 and a 2-by-2. Right, like that. And then that would leave you with, you need 8 other squares. Which, yeah, I think you could do that. You put 8 in here and 8 in here. Right, so that's 10 squares. 2 of them are 2-by-2s, and 8 of them are 1-by-1s. and that would make a 4 by 4. Okay, so that actually works. You could do B. What's the smallest possibility of the length of side? Okay, so B does work. All right, well, that was nice. I thought that wasn't going to work and we have to keep going, but all right, how are we doing on time? 15 minutes left, and we have like 9 questions to go. Okay, I got to pick this up here. What is the smallest positive integer that is neither prime nor square and that has no prime factor less than 50? No prime factor less than 50. All right, well, what's the next prime after 50 would be not 51, that's a multiple of 3, 53, I believe. Okay, so it's 53. But if it's not prime, then it can't be, and it doesn't have any other prime. It's got to be 53 times the next prime, which the next prime is not 55, not 57. That's also multiple 3. 61, I believe. Jeez, I should know this. My old students would be very disappointed in me if I don't know all the primes off the top of my head. All right, so I think you just multiply those two numbers. Smallest positive integer, neither prime nor square. Okay, yeah. If it could be square, you just do 53 squared. All right, well, I'll just multiply these out. 53 times 60. I'll do 50 times 60. That would be 3,000, right? 5 times 6 times 10 times 10. Then 50 times 1 would be 50. 60 times 3 would be 180. And then 1 times 3 is 3. So it ended with 3. 5 plus 8 is 13. Carry the 1. So we get 32, 33. They found one smaller than that? What am I forgetting? Oh, 59. Okay, my students would be disappointed in me. Okay, I got lucky that wasn't an option. So 53 times 59. Okay, well, 53 times 60 would just be 3,180. And then we're subtracting another 53 from that. So that would be 3,127, which is option A. Okay. All right, well, I just burned some of my time for no reason, but we'll keep going. In a jar of red, green, and blue marbles, all but 6 are red marbles, all but 8 are green, and all but 4 are blue. How many marbles are in the jar? Okay, so the red plus the green would give you 4, right? Because all but 4 are blue. And then that means the red, if they're all but 6 are red, so that means the green plus the blue is 6. And then the red plus the blue is all but green, which will give you 8. Okay, so you got all of this. How many marbles are in the jar? Well, they're all red. So if we just add these all up, we get 2 reds, 2 blues, 2 greens. So we just divide that by 2. All right, so we get 4 plus 6 plus 8. That's 10 plus 8 is 18. So they're 18 if we have double of everything. So 2R plus 2B plus 2G. And then just divide both sides by 2. We get R plus B plus G is equal to half of 18 is 9. Okay, so that one would be C, 9. What is the correct ordering of the 3 numbers 5/19ths, 7/21st, and 9/23rds in increasing order here? Okay. Well, all of them are what? You're increasing both the numerator and the denominator by 2. All right. I'm trying to think if there's an easy way to explain how I would think to do this. I would guess that it's basically like this is the smallest, then this one, then this one. And I don't really know if that's so much of a guess. It's just basically like adding 2 to the numerator. 2 is a bigger chunk of the half, basically, or of the thing each time. Or it's a smaller chunk each time you go up, right? Wait, no, that's wrong. No, I think it's actually this order. Okay, whatever. I'm going to come back to this one. I'm going to go to 21. I think this one, I feel like I'll see how much time I have, if I can just brute force that one or if there's a trick that I can figure out. But anyway, Marla has a large white cube that has an edge of 10 feet. So it's 10 by 10 by 10. So it's, what is that, 1,000 cubic feet. for the volume. She also has enough green paint to cover, oh, they're going to do something surface area. 300 square feet. Marla uses all the paint to create a white square centered on each face, surrounded by a green border. What is the area of one of the white squares in square feet? Okay. Does it say, including the one that's on the floor, right? So what I can do is just find the total surface area, which is 10 times 10 times 6. So each side is a 10 by 10 square times 6. So that'd be 600. And then we can only get 300 of it. So 300 of it is green, which leaves us with 300 total square feet that are not painted, that are white. Now, what is the area of one of the faces? Well, I just divide that by the number of faces, which is 6. So divide that by 6, and that gives us 50. I think that's the easiest way to do that. Let R be a set of 9 distinct integers. 9 distinct integers. 6 of the elements are 2, 3, 4, 6, 9, and 14. What is the number of possible values of the median of R? Okay, so they're integers. Does it say they're positive? Distinct integers. Oh, it doesn't say they're positive. Okay, so basically, like, what could be the middle? Well, right now the middle would be between, what, 4 and 6? Is 1, 2, 3, 4, 5, yeah. So it's between these two. So there's 3 more spots we're going to put in. If we put it somewhere on this side, like, let's see, if we go, like, 1, I don't know, if we put 1, 2, 3 on this side, then that would mean that it would be 1, 2, 3, 4, 5. It'd be 9, right? 5 would be the median of 9. If you put 3 on this side, 1, 2, 3, it'd be 1, 2, 3, 4, 5 would be 3. So it could either be 3, 4, 6, or 9. I think those are the only possibilities. So it says, what is the number of possible values of the, or the middle could be the number you add in. So we have to figure out, it has to be something between 3 and 9 then, I believe. But you could have it be 5 or 7 or 8, or you could have it be, I don't think you could have it be 1. Yeah, so 5 or 7 or 8. Can it be 10 is the question. I don't think so. No. So it's either 3, 4, 5, 6, 7, 8, or 9. So what is that? Just 9 minus 2 is 7 possibilities. That was close. I almost circled 4 there. That would be very dumb. All right. I think that's correct. Let's see how we're doing on time. 7 minutes and 30 seconds. And an equilateral triangle and a regular hexagon have equal perimeters. Okay. So equilateral triangle and a hexagon. I'm drawing this hexagon right. Does it say it's a regular hexagon? Yeah. If the area of the triangle is 4, what is the area of the hexagon? Okay, well, actually, the way you find the area of the hexagon involves equilateral triangles. You'd like divide it into, 6 equilateral triangles, I guess. Did I draw that right? Yeah, I'm missing a line there. So we know that the side length of this one is, let's see, like 3 times the side length of the equilateral. Let's call that Q for equilateral, is equal to 6 times H, the hexagon. So basically, the equilateral triangle has sides that are twice as long as the hexagon. Now, to find the area of the equilateral triangle, you need to find the height, which you do 30, 60, 90 right triangles. I actually memorized this. So the height is going to be S root 3 over 2. And if you want to find the area, it would be S squared root 3 over 4. So S squared root 3 over 4, because you have to do 1/2 times base, which is S, times height. Now, in this case, if the area of the triangle is 4, this is equal to 4, and this is S is supposed to be Q here, right? So Q squared times the square root of 3 is equal to 16. Now, over here, if you have these, they're half the size. So this is like Q over 2, right? Half of Q. Basically, you have 6 of those. So it's like Q over 2 squared root 3 over 4, but you have to multiply that by the 6 of them that you have. So that would be, let's see, q squared over 16 times square root of 3. I'm just doing half squared is 1/4 times 6. So that'd be basically 3q squared root 3 over 8. Well, we know that q squared root 3 is 16, so I'll put this as 16. We get 3 times 16 over 8. Well, 16 divided by 8 would be 2. So we get 3 times 2, which is 6. So the area should be 6. That's choice C. All right. Hopefully I didn't go too fast through that, but I have 4:45 left. Okay. And I skipped number 20 too. All right, well, let's go really quick here. A circle has a radius of 2. It is cut into 4 congruent arcs. The 4 arcs are joined to form a star figure shown. What is the ratio of the area of the star? So star to the area of the original circle. Okay, well, if the radius is 2, then the area of this is pi r squared, which is pi times 2 squared, which is just 4 pi. Right, so this thing is 4 pi. And then this one is just, you've got that same circle there, like this chunk and this chunk and this chunk, and you're just subtracting it from this square that is also, what is the radius is 2? So it's 2 plus 2, 2 plus 2. So it's a 4 by 4 square, which is an area of 16, and then you're subtracting that circle from it. So 16 minus 14 pi is the triangle thing here, or what do they call it? A star. And what is the ratio of that area? So the ratio of this area to the area of the circle, so you just divide it by this 4 pi. All right, so this should be your answer, but you can simplify that by taking 4 out of everything. So divide the whole top by 4, that gives you 4 minus pi, and the whole bottom by 4, because 4 divided by 4 is just 1. So 4 minus pi over pi, which would be A. Okay, that one is actually not too bad. All right, 3:30 left. Let's hope that this one's not a doozy. A square with area 4 is inscribed in a square with area 5. Okay, so this inner square is 2 by 2, right? Because it's got an area of 4. This other one has side lengths, so it's area 5, so that means it's square root of 5 by square root of 5. Okay, with one vertex of the smaller square on each side of the larger square, so we can see that. A vertex of the smaller square divides a side of the larger square into segments, one of length A, one of length B here. And the other, okay, other length B. What is the value of A times B? Okay, let's see. Well, what I'm seeing here is A plus B adds up to this square root of 5, because it adds up to the length of that entire side, right? Now, we also know that this is 2, right? So we can use the Pythagorean theorem here, and we get that A squared plus B squared, right? This side squared plus this side squared, the legs, would add up to 2 squared, which would be 4. The hypotenuse squared. All right, so A squared plus B squared equals 4. And we want to find AB. Okay, I see what we're doing here. So since we have A plus B equals the square root of 5, we can square A plus B. So square this, which means you have to square this. That gives us, well, if you square A plus the quantity A plus B, it gives you A squared plus 2AB plus B squared equals square root of 5 squared is 5. And then we just subtract, we use elimination, subtract A squared, subtract B squared from both sides, and subtract 4 from both sides. You're subtracting the equivalent, so it takes away the 4. Okay, we got like a minute 30 left. So minus A squared minus B squared minus 4, that gives us that 2AB is equal to 5 minus 4 is 1. And we want to find just 1AB. So we're going to divide both sides by 2, which gives us that AB equals 1 over 2, which is 1/2. So this one is C. Okay, so I've got it. Now I have a minute 15 to solve this thing with the fractions. Okay, I think I can just probably brute force this. Let's see. Okay, can I brute force it? I don't know. If I don't get this one, I'm going to be mad at myself. All right. Well, half of 19 is 9.5. So it's 9.5 over 19. Half of 21 is, what is that? That'd be 10.5 over 21. And we've got half of 23 would be 11.5. So which of those is like closest to the halfway mark? I would say Yeah, 9/23 is definitely the closest. So that's got to be the biggest. So I think it's literally just this order. So I'm going to circle that, which would be choice B. So I'm going to go with B on that one. Now, I can actually verify that if I have 15 seconds. I don't know if I could verify that in time. But I mean, just looking at it like that, I'm kind of eyeballing it, and it's like it looks way closer to it. And also, taking off 2 out of 19 is a bigger deal than taking 2 off of 21 and so on to 23. All right, so that's our time. All right, well, I answered everything. 20 is maybe I feel pretty confident about it, honestly, but I kind of wish I had actually shown some work. There's probably a faster way to do that one. But yeah, I got an answer for everything. I will now pull up the answer key, so just bear with me while I find this. It's 2012. All right, so 1 is E, 2 is B, 3 is B, 4 is C, 5 is E, 6 is E, 7 is B, 8 is D, 9 is C, 10 is D, 11 is D, 12 is A, 13 is C, 14 is B, 15 is D, 16 is C, 17 is B, 18 is A, 19 is C, 20 is B, 21 is D, 22 is D, 23 is C, 24 is A, 25 is C. All right, so those are our answers. I'm going to write these down. Just probably cut this out while I write down all these answers. Okay, and now back to the exam. Let's go through these. So we have, let's do it in green. So I got 1 is E, correct. 2 is B, 3 is B, 4 is C, 5 is E, 6 is E, 7 is B, 8 is D, 9 is C, 10 is D, and 11 is D, and then 12 is A, 13 is C, 14 is B, 15 is D, 16 is C, 17 is B, 18 is A, 19 is C, 20 is B, 21 is D, 22 is D, 23 is C, 24 is A, and 25 is C. So let's see, A and C. Okay, we got all 25, perfect. And 20, I want to see if there's a solution for 20. Let's go look what they did for 20. Oh, okay, that doesn't really seem like, I mean, yeah, okay. They just got them all to have a common denominator. But I was not trying to multiply them all, but oh, okay, but that was kind of nice. You could change, what was it? 7 over 21. I didn't even think of that. 7 over 21 is 1/3. Oh, wait a minute. Okay, yeah. This is what you should have done. Oh, wait, no, they have it down here. 7 over 21 is 1/3. Yeah, that's the smart way. That's the smart way for sure. So let me actually show you. 7 over 21 is 1/3, right? So this is 1/3. And then you just can figure out if 5/19 is bigger or smaller than 1/3 by being, not by looking at the 19. I mean, you could find 1/3 of 19 if you want. It wouldn't take that long. But I would go, okay, what's 5 times 3? 15. So 5/15, if you increase the denominator from that, it's making it smaller. So this is less than 1/3. And then for 9 times 3 is 27. So 9 over 27, that's smaller than 9/23. So 9/23, by decreasing the denominator, you made it bigger. So this is bigger than 1/3. So that's definitely the smart way to do it. I actually think one of my students, I think I remember who it is, but I don't know, say my student's name. I'm pretty sure one of my students thought of this, because I've definitely done this set at some point with my students. So this isn't my first time taking this test. I definitely took it as a coach at some point. I would usually do the problems with the kids so I can explain the interesting ones. But yeah, so that's how you get all of those questions in time, including giving explanations for what you're solving. I will say, I think some of the more recent ones, I'll probably struggle a little bit more to get them all done in 40 minutes while talking, because I know they've kind of upped the difficulty each year. Maybe not every single subsequent year, but like between 2012 and 2026, I'm sure there's a pretty big gap. But yeah, I'll probably timestamp these. I didn't timestamp the last ones yet, but I'll put those in. But yeah, if you're prepping for the AMC 8, keep at it. I think doing practice problems is the best way to get that down, and just make sure that you actually review the things that you didn't get. If you guessed one correctly, I always recommend put a little star next to that one so you know to review. So you could be like, all right, well, I guessed on this one, or I brute forced it, but I want to see if there's a better way to do it. Now, one of these, I think I started to come back to it. How many 4-digit numbers? Oh yeah, this one I was just saying you could brute force that to prove it if you wanted to. I guess we could do that really quick if there's only 9 of them. So you could do like 2210, 2201, 2120, 2102, 2012, 2021. All right. So there are those ones that start with a 2, and then you can do one that starts with 1, which could be 1220, 1202, 1022. Okay, so you got 6 here and 3 here. What they could have done, I wonder if there's a way that you could have worded it that you had to exclude 2012. That would have been annoying because I probably would have forgot to do that, like to rearrange the digits of 2012 to be a different number or something like that. That would be a really annoying problem though. But yeah, I guess so that was probably just as fast as doing it with the combinatorics or whatever I did. And maybe there's a little less room for error. But yeah, if you do it, just make sure you're doing it systematically. But yeah, anyway, yep, keep at it, guys. And I guess if you're just doing this for fun, I think it's a really good way to keep your brain sharp. You can find all of these questions on The Art of Problem Solving. They have all of the old AMC 8 exams on there, as well as answer keys and solutions. So, I'd recommend working through those if you are either prepping for a math contest or just if you are looking for something fun to do. I enjoy it. All right, well, take care, and thanks for watching. Appreciate y'all.